So this is kind of like the hello world of procedural audio, or DSP in general. We've got our frequency. The main object over here is the OSC object, okay? Has anybody in this room never used PD before, pure data? Okay. All right, this is where people get caught out, right? Well, basically, like a new PD patch looks like this. It's a blank screen. The key thing is there are two modes. There's edit mode and, well, not edit mode. And you toggle between them using Command E on a Mac or Control E on a PC. And if you're in edit mode, you'll see a hand like this, and you'll be able to do this. And if you're not, you'll just see a cursor. Okay. Also, there's a DSP button here. If you yeah, don't use. Which brings us to our next lesson of PD. Try not to use headphones. There's a technique of using headphones with PD when you're doing this stuff is put it like over here or behind your ears, just enough so you can hear, you hear enough, but if it goes above, like, like got white noise going at like maximum dB through your headphones, you're not going to be deafened by it. Yeah. Really important lesson, that one, actually. So yeah, this is our main object. This is generating a sine wave. Over here, we're setting the frequency. This object here, $50 going into a line. The line object is basically creating an audio rate ramp. So it's saying whatever value I give it, over 50 milliseconds, interpolate to that value. Okay. And I'll show you the effect of this. So I'm going to turn the audio on. Whoa, what's going on here? There is none. Just use a limiter. Why? Sorry about that, guys. Is that happening for everybody? Really?
Let's try.
Sorry, I'm just checking what's going on here. That's really weird. It's not meant to sound like that. Is everybody getting the same problem with this patch? Ah, right. Okay, nice spot. Okay, let's go into this patch. That's my fault. Sorry, guys. I've deafened every one of you. the gain slider is set to 0 to 20,000 instead of 0 to 1. Because I copy and pasted this slider, which is 0 to 20,000. Okay. So the way to fix that is if you right-click, go on Properties, close this window. Wait, no, don't close that window. Here, and change the upper range to 1. That will fix it. There we go. Okay. So this also explains why it was working in Heavy, but PD was giving the sound problem. Okay, but don't worry about this patch. That's my bad. So let's look at these two objects over here. Receive frequency and receive gain. Okay. So normally in PD, the send and receive objects are used to, as you'd expect, send values from one part of the patch to the other part of the patch. So for example, if over here I were to say send some value, and I put a number box into it, and I change this value, it's going to be received over there, okay? That's all the receive does. However, if we add this suffix to the object, at heavy param, and then these three numbers, this represents the minimum value, the maximum value, and the default value, okay? Then this will expose the receive object as a parameter in Heavy. So that means, inside that Unity script where we could say heavy audiolib.parameter.frequency, it adds it to that list, basically. And we can have as many of these parameters as we want, and this is what we use to get control from the outside, okay? So let's look at a more slightly more complex patch. We can look at NYPD, for example. All right, yeah. All right. So let's go through this one by one. If you're opening a patch for the first time and you're trying to understand what's going on, it really varies from patch to patch, and there's some very, very badly written patches. But in the case of a neatly written patch, the best thing to look at is at the very bottom of the signal chain. So if you take your audio output and you follow all the way back upwards, that's probably the best way to start analyzing in a patch what's going on, okay? So in this one here, we've got our output over here, DAC, digital audio converter. These are our two audio outputs in Heavy. Over here, we've got a multiply object, right? So this is scaling our audio output based on a parameter coming from here. We see here there's a low pass and a signal. What's happening here is we're turning a value from control rate to signal rate. So this is another weird thing about PD, but something that makes a lot of sense when you think about it, is that we've got control rate and audio rate, right? So audio rate is our sampling rate frequency, which in this case is probably 44.1 kilohertz. So that means 44,100 times a second, we're going to get a new value calculated, and that's how we calculate our audio. So all our objects with a tilde in front of them, this one as well, if there's a custom Heavy object, all these are signal objects, okay? These ones here, on the other hand, they're control rate, and all these messages as they come in, they're done at control rate. So in Unity, when you're sending a message in, it's going to activate something here, and it's going to activate all these calculations just for that one time you send in a value, okay? Whereas for audio, if you set a value here, it's always going to, it's more like water or electricity flowing, whereas here it's more like setting switches, okay? So what we're doing is turning a control rate value into a signal, okay? So whatever this value is going to become a signal of either 1 or 0, I think. Yeah, depending on whether this enabled is set to 1 or 0, okay? So let's go up. This is basically making the enable functionality. Here we've got a filter. Now, all the objects starting with heavy dot are objects from the so-called heavy lib. And it's a bunch of PD objects, which are, they're just really useful. Like the filters are much more reliable than the PD filters. They sound better. And the oscillators have some more wave shapes. So there's a square waveform, for example, here that we're using. So square oscillator. VCF is Heavy's version of PD's VCF object, which is a filter, a bandpass filter where you can set the frequency with a signal. If that all that means nothing to you, don't worry too much. Basically, it's a bandpass filter. And we are changing the Q factor over here based on this ramp signal. So we've discovered there's this ramp object. Where does that ramp come from? It comes from here, okay? And if we look here, we see we're using the same ramp signal over here as well to control the frequency of the square wave oscillator, okay? So basically, the signal guts of this model are over here, square wave through a filter. We're changing the frequency and we're changing the cutoff and resonance of the filter as well. Now let's look at our ramp generation over here. We've got our three inputs coming in, whale, yelp, and piercer. Okay. Now these are similar to our heavy param receives, except that here we've specified heavy event. Okay. I'm not sure if this is supported in all the platforms, but definitely in Unity it's supported, that when you specify event, it will show up. Let me just show you. Okay, it will show up as buttons, okay? Because an event is just a trigger, just an impulse, basically. Okay. So receiving these from the game, also if it's enabled or not, and it's setting these values to a phasor, okay? Now a phasor signal is something that goes up and then down and up and down and up and down, like a sawtooth, inverse sawtooth wave kind of, and its range is between 0 and 1, okay? So as you can see, these are very low frequencies, 0.2 hertz, 3.33 hertz, and 10 hertz. Over here, this is maybe a little bit fiddly to explain right over here, but it's basically some signal rate logic. So I'm doing some waveform shaping by using these operators. Basically, if you have a phasor, you can, what we're doing is we're changing the range. We're doing a test to see whether it's above 1 or below 1 at audio rate. So heavy GTE is heavy greater than or equal. Then we're doing some mathematical operations on it to end up with a ramp signal. Now, I don't think I've provided this object. It's one of my objects, but I can provide it later in the workshop. I'm going to send a new version of the materials, which will include it. But with this object, you can scope the signal. So we can see what's going on over here. So that's our phasor object. Actually, let me make a big one. Okay. That's our phasor object. Okay. Now let's say we just plug this straight into our ramp like this. Let's see what happens. You see? So here we can see what this ramp is doing, how it's affecting this kind of signal chain over here. So let's see further down the line how these operations change. we're multiplying by 2. Okay, so that means it's going to keep going above the range. We're checking whether it's above or below 1. Okay, so this should switch between 1 and 0. See? Is below 1, is above 1. Is below 1, is above 1. Okay? So that signal we're using to generate this signal over here. And we're multiplying it by this signal again. Oops. To end up with this signal here. Okay? And we're taking the absolute value. So we take the absolute value. That means it's not going to go below, because if we were to plug this directly to our ramp, okay, and we don't want to do that. So we want to take the absolute value, and we end up with this kind of signal, okay? So now that we've done that, we've understood that our ramp, all this is doing is generating a signal that goes up and down linearly, okay? It's a triangle wave, basically. And now if we change the frequency, we'll see how that affects the sound. So this is on 0.2 hertz. If I go up to 3.33 hertz, okay, up to 10 hertz, okay. Okay, and I guess this is quite illuminating because I explain it. In a way, it's weird that it's so simple to make the police sounds, but on the other hand, if you think about the, the machines, the siren generators, it is a very basic operation. It's just changing the frequency. So it's like there's a good example of something where perceptually, when you hear the sound, you hear police siren. But if you think about it more mechanically or more technically, it's actually a very, very simple signal operation, basically. Okay. And so this kind of process, we've just done the reverse, the analysis process. But like when you're making these objects, these sound models, you probably want to look into, you can either listen to a sound and see how it changes and try and capture those behaviors with operations like this. Or you can go on Wikipedia, look at the siren, see how it works, see what the input parameters actually are or the mechanism, and you design it from the ground up. Those are the two different ways. And the police siren is an easy one, but you might have some more complex models. So, for example, here's a model I made about 3 or 4 years ago for Bela, for the Bela board, when I was helping out with that. It's the infamous rubber ducky model. And basically, there's one single parameter called squeeze me. And it's a rubber ducky. So this is, again, this is definitely more complex than the police siren. It is a very simple, maybe not simple, but a very basic simulation of a reed. Okay, so basically when you blow into a reed like a clarinet or a rubber ducky, you're going to get a stable range of frequencies with pressure. You're thinking of pressure, right? So as the air pressure going through the reed increases, you're going to get a period of just noise going through. And once the pressure is hard enough, the reed's going to start vibrating. And as you increase pressure, it's going to vibrate faster and faster. So you're going to get a higher frequency. Let me demonstrate. All right. Blowing harder, 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 and then you overblow it. You just get the air. And that is what happens with a reed, okay? So the way this model was approached is that the first thing to simulate was how do we get this reed behavior? And I'm not going to go through the patch. You can, shit, that's not meant to be there. ignore these. I'm not going to go through the patch, but I've kind of commented it a bit, and you can see maybe try and get your head around how it works. But it's fairly simple. It's similar to the MYPD model in that you're checking for boundaries, whether it's overstepped the boundary. In that case, change the signal this way, combine noise and oscillation, and you get that model. So remember when we were using the whoosh model, the whoosh sphere, we had to calculate the delta, the velocity, from take the previous position, divide by time difference, and you get your velocity parameter. In this case here, this calculation is happening inside the patch itself, right? So we could make a version of this model, which is just like this. It just takes the input parameter, and you control it like that. Sorry. But in this case, we're doing the control over here. So what's happening here is an audio rate delta calculation, okay? This is, again, like slightly advanced for like the first time using PD, especially in audio rate, but it's basically a zero pull filter. And the reason this object is very useful is not because we want to design our own filters, but because what this calculation does is it gives you, what's the best way to explain this? It gives you this calculation, basically, okay? So imagine y of n is our current output sample. Y of n is like whatever is currently being calculated and coming out of the speakers. X of n is our previous input sample. And A of n is our argument over here. So what that means is if A is set to 1, then what we're going to get is the difference between x of n and x of n minus 1, okay? So if you use R0, 1, you've basically got a very simple audio signal differentiator, okay? You calculate the differential. Obviously, you have to take the sample rate into account because you've got to divide by the time step, which is the time it takes for one single sample to occur. Okay, so now that might be slightly complicated, but if you go back and go through the patch, you'll understand why it's there and what's going on.
Sorry, do you have a documentary for that? Because it's a little bit hard to follow, but it's really interesting. Something to read through, just how it works.
For the ducky, I don't think I ever did, no, aside from commenting the patch, but
I mean, yeah.
There's 2 blog posts were done on the Enzian page for the Rick and Morty, the Morty face. I don't know if you've seen it. I can show you that later. And one for a zip. It's not, because the whole page is down right now. There's something I'd love to discuss at the end, actually, like the future of Heavy and how we're going to keep all these resources together, you know, because basically the company is just closed, like, yeah, just over a month ago, you know. It's still in the process of closing down at the moment. So all this stuff is very new. We're still figuring out how to keep this maintained and so on. We need developers and a maintainer, actually. And that also applies to where we put these resources. If we start a forum, so I'd love to hear like, your opinions on like, how we'd go about doing that. Okay, we're kind of like running out of time now, so I thought I'd go through the Heavy CC setup so that you can compile your own patches. Yeah.
When you compile, you don't use libpd, or it's
No.
not PD at all. You just pass and you get things generated from your own code.
Yeah, yeah.
This is actual PD, right?
This is actual PD, yeah.
And you use heavy components inside.
Mm-hmm. So all the heavy all the heavy objects have been carefully tuned to replicate the behavior of the objects. So we've got our own filters, for example, but if you use, say...
So they are supported in PD? Right?
Yeah. Yes, so most of the objects in PD vanilla are supported. FFT isn't supported. Potentially a few others, but the core components are all supported. Obviously, there's no extended objects or libraries, but yeah. But yeah, let's talk about the compiler now.
The heavy alternative objects still available for us?
Yeah, they're actually included inside these objects. Not all of them. Some of them, I think some of them have the entire thing. Well, these are all like very old versions of them. I wouldn't use the. Yeah, here you go. That's the latest one, I think. Yeah, so this is HeavyLib. There's a bunch of like helping objects. So there's it's a comb filter, this compressor, stereo compressor, envelope follower, filters, like some very good sounding filters, you know, because you don't want to be using PD's filters. Flanger, or greater than, less than objects, and so forth, and they're on oscillators and pink noise. You can find that on GitHub, on Ensign Audio's GitHub. There is, next to the Heavy CC, the compiler collection, there's also HeavyLib, and HeavyLib is a collection of PD objects. The reason this is all possible is because of Heavy CC. It stands for Heavy Compiler Collection, and as it says on the GitHub page, it's a Python-based data flow audio programming language compiler that generates C or C++ code and a variety of specific framework wrappers. Okay, so I've kind of gone through what Heavy CC does, but just to reiterate, Heavy CC is like literally a Python compiler. It's literally taking the text from the PD patch, figuring out what the graph is from that PD patch, making a new representation of that, and rebuilding the patch based on a very limited set of objects. Okay, so Heavy has its own oscillators, its own multiply and add objects, and everything's platform dependent. Okay, so if you run this same patch on a PS4 with SIMD optimizations or whatever, it will run different codes compared to if you were to run it on the web or on the phone. Okay, so it's all done automatically. But this also means that in Unity, for example, we have to compile different plugins for, it means that in Unity, we have to compile different plugins for Windows 64-bit, Windows 32-bit, and Mac OS X and Linux. So that is why, for example, like in the Unity, I already gave you all the pre-compiled binaries, you know, but if you're doing it with your own patch, you'll have to make sure that you're compiling the right ones. Okay, so feel free to not follow this, or to, like, I'm going to give the slides and you can go through this in your own time, because it's quite a lot of, like, potential sticking points where, like, you don't have the right Python version installed, or you need different 3 different Python modules, or Xcode isn't installed, but I'll walk you through the steps. So I've already given you Heavy CC, but you can clone it from GitHub using this command over here, or you can just download the URL from here. And the one file that we're interested in is heavycc.py. So if you type Python heavycc.py, I'll just do it now, actually. So we open a terminal window, go to, where is it? Okay. So inside Heavy CC, I'm inside this folder now, and I can type Python. Also, by the way, like when you do this, you might want to do which Python, and you might want to make sure, sorry, not which Python, you want to do Python version, and you want to make sure that you have Python 2.7 installed and not 3. There are ways of having both 3 and 2.7 installed on the same machine, but all this is only going to work in 2.7. Unfortunately, when Python got updated from 2 to 3, it made some very, very drastic changes, which means that half the world is stuck on 2.7, the other half on 3. That's just the way it is. Anyway, so we type Python heavycc.py -h. Okay, we're going to get our usage information here. So it will only work if you give it the right amount of argument, if you specify like most of these arguments. So you need to give it the output directory. Let's start backwards. Okay. So in path is the path to our top level PD patch. Okay. I know it's a lot to take in at once, so don't worry. You know, it's and you'll forget it again. And but like when you come back to it, it should be a bit easier to navigate. So when we say in path, what we're talking about is our main file over here. Inside ducky, or if we wanted to compile meep, it would be here. And you have to specify the PD file itself. Obviously, if you have a different top-level file, like main2 or something, you can specify that, and it will include all these patches, which are called inside main, okay? Like abstractions. So let's compile a patch. I'm going to say python heavy cc.py. And now we can go through all the arguments. So output directory is where it's going to place all our compiled files. So I can say -o, and I'm just going to put it in a folder called HV, which is next to heavy CC. So I'm going to do /HV / and I think I'm going to compile ducky. So I'm going to call it ducky. And then, so search paths is useful, right? If you're, I'll talk about that later. I'll explain search paths soon. You don't need to use it, but it can be useful. Next one is name. You need to give it a name. If you don't give it a name, it's not going to be able to generate anything. So let's say, call it ducky. Actually, I'm going to call it Robert Ducky just to be sure. No, I'll call it ducky. What else? We need to specify what we want to generate. So by default, it's just going to generate C files. But in this case, we want to generate Unity files. Again, my internet isn't working, but if you go on the GitHub HeavyCC repo, there's all the documentation there. And if you click on, actually on the top, on the front page, it'll list all the generator types you can specify. So for example, C, Unity, Wise, JS, VST2. So I'm going to generate Unity. And we also need to give it a copyright, otherwise it's not going to run the script. I think that might be a bug in the current state of the code. Copyright grandma. And then we specify our input path, okay, without a minus anything. So our input path is, I think, /pd, yeah, ducky. And we need to specify our top-level patch, which is main.pd, okay? So if everything was installed correctly, Python and all our dependencies, and we press enter, that's done, okay? It's generated everything we need. Here we have a warning. We've accounted for that warning in the patch, so we can ignore it. But it's actually one to look out for. So we've generated our stuff. So let's go to heavy. This is our output folder we specified. And I see a folder called ducky, which has been created. And now here we get to the interesting bits. So we've got 4 folders: C, heavy, IR, and Unity. Okay. So these two correspond to the diagram I was showing earlier. In order to generate the C, it needs to generate this intermediary language, which is a JSON file that says this object is here, that object is there, there's a PD object, this is actually an internal heavy object, and so on. It puts everything together, and that generates our C code. So one thing, let's have a look at the C code just for fun. Let's look at the entire folder over here. First of all, let's look at the size of the C code, okay? 11 kilobytes, 33 kilobytes, okay? So 33 kilobytes is a lot of code for a C file. It's actually not too much for a model. I've had models where the C code itself was 2 megabytes. So that's 2 megabytes of plain text, okay? The reason for this is that in order for Heavy to work the way it does, it needs to create its own, everything is fixed, okay? So the graph doesn't change. In PD, you're constantly adding, removing objects. Here in Heavy, it's fixed. It's just like making a signal path and it's firing all your samples through it. And you're getting the output. So all the code is fairly strongly obfuscated like this for various reasons. And the point I'm trying to make is that this code is not readable. Or it is readable, but it's not, you're not going to want to dig into this code and change anything. Because that is not the point of this code. The point of this code is to have something that runs very, very fast and that can be wrapped into something else, okay? Here we've got a lot of static C. I mean, I'm not sure how much you need to know this, but basically these are like Heavy's internal objects. So binary operation, this is like all the pluses and minus, add, subtract, multiply, delay, phasor. Notice, for example, we have no Heavy signal OSC object. That is because our oscillators, the filters, everything is made out of these smaller scale components. Okay, so the phasor, our sine wave oscillator, or rather Heavy CC's sine wave oscillator, interpreters, there we go. So all these objects you see here are objects that have been rewritten in PD to work in Heavy. So if we look at the oscillator object, for example. Okay. All right. These are all PD objects, and it's a Taylor series expansion of the sinusoid function. So this isn't actually a mathematically true representation of a sine wave, but it's good enough, okay? And it's much faster than if we were to replace this patch, with this object over here, which is an actual trigonometric calculation of the cos or the sine, okay? So there's lots of optimizations in PD like this to make sure that everything runs as fast as possible. Okay, so just a little like tour of Heavy and how it works, Heavy CC. Okay, let's go back to our generated output, Ducky. This is all well and good. You might want to use the C stuff if you're making your own wrapper, or you're working, say, like on a project where they've built their own audio engine, and you know they're like, oh, I wish we could have this like rubber ducky model or some wind model or something, and then you can say, oh, but we can do it with Heavy. But you're using your own audio engine, so then you can go to the audio programmer, or maybe you can figure it out based on the materials you have, find the audio callback, load this, and there's a basic API for putting this inside your C projects if you want to do this on a lower level. And it's all very well documented. And it's C++ as well as C, so you can do things like instantiate multiple objects and so on. Yeah, yeah. However, all these are static and they don't change. Right. So for example, oh yeah, 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 you can. Like so, for example, for Billa, we ended up, I think it's still doing it that way. Yeah. Instead of constantly moving all these files into the folder, we've just compiled them into a static library, and then you're calling the static library the .a file. Yeah. But yeah. Anyway, let's look at the Unity folder because there's the stuff that's relevant here. We've got Android, Linux, Visual Studio, and Xcode folders. So what Heavy CC has done is it's created Xcode projects and Visual Studio projects, a Linux makefile, and I don't actually, yeah, well, Android makefiles. So what you need to do is, on the relevant platform, you need to compile the project, because this needs to be done in a separate command. So if you're on Mac and you have the Xcode tools installed, I think you can cross-compile in certain instances, yeah. Yeah, the thing is, we've been so reliant on so when we had the cloud compiler, this was actually really useful, not just to the rest of the world, but to us as well. Like, for example, preparing this workshop, yesterday I had to, preparing the files yesterday, I had to go through every single patch on my Windows machine and the laptop machine. There's probably a faster way of doing it, but at the moment it's actually, unfortunately, a little bit more time-consuming to do this than it was with the website. But again, this is something that can change in the future. So over here, there's a command that you can paste into the terminal if you've got Xcode installed in the command line tools. So what I'm going to do is I'm going to navigate into the folder I've just made, Heavy Ducky. In here, I'm going to go into the Unity folder, and inside the Xcode folder, this is for Mac, yeah. I'm going to paste this command. So heavy whoosh Unity doesn't exist. That's because I pasted the wrong name of the Xcode project. So if we rename it to what it is, it's Ducky. And we press enter. That should all be fine.
Could you just shift the terminal window up a tiny bit?
Oh, yeah, of course. Yeah. OK. So over here, it says build failed. But you can ignore this, because this is just because we're only compiling for one type of architecture. By the way, you can also, if you have Xcode installed, just open this in Xcode. And you can build it manually, okay, with over here. OK, so now we've run this command, and it's the same if you run Visual Studio, the Visual Studio file. And if you are on Windows, I find it actually easier to just open the Visual Studio project and do it from the command line, because there's always something broken about the command line approach. So the main thing here is that we've created this has created a new folder called build, okay? And inside that build folder is a Mac OS folder and x86-64, so it's for both 32 and 64-bit, or for 32-bit architecture. And here are suddenly files that might look familiar to you. This is our audiolib library, which gets called by our C# script, okay? So if we go back to our, I'm going to make a new project right now, okay? Don't, just to demonstrate something. Okay. Okay, you might have noticed, by the way, it generates two plugins. One is called Heavy Ducky Audiolib, and the other one's called Audio Plugin Heavy Ducky. That's because Unity takes two kinds of, there are two types of ways of generating and processing sound in Unity. One is to, if we look here, this is internal to Unity's audio engine, so it has different mixers. And on the mixer, you can add an effect, okay? And you can make different effects. So even here, if I were to add this Ducky audio library, it would appear as an effect over here. But for the purposes of the stuff I was showing you today, you probably don't want to be working with audio mixer plugins. You want to be working with these C# plugins. So basically, this is a script which handles all the calling of this library and sending it to the audio output and getting the parameters and so on. So if this were a new project, I would, and it is a new project, I would say create new folder and call it heavy, or you can call it plugins, whatever you want. I'll make a new folder and call it Ducky. And then if I wanted to be really, neat about it, I would create another folder called macOS. And put this object, the bundle, the Heavy Ducky Audio Lib bundle, into here. And you can put the script into here. Having said that, you can also just copy these two and put it in here. But it's better to do it the neat way, because if you're shipping your game or your project and you're building for Windows as well as OS, and you can go through all the plugins and you can make sure that all those plugins are there. If you're on Windows, you're going to end up with you're going to end up with two folders, x64 and another one called x86. Okay, so that's 64-bit and 32-bit. So if you import this plugin, like let's say I was making a Windows plugin of this. Create folder win. X64. Okay, so if I were to import this DLL into here, because they have the same name, okay, the 64-bit version and the 32-bit version, they share the same name. So, and you also need to specify the architecture. So you need to click here, and in the inspector, you're going to get these two platform settings, depending on the platforms that you installed in your Unity installation. So you want to make sure that 64-bit here, and here 64-bit, and Windows. Then you apply. Because if you don't do that, you're going to get conflicting plugins, and it's going to complain, and it won't run your project. Okay, so just a heads up for that. Yeah, but that's basically it. With Unity, another slightly annoying thing is, I'm not sure how it is for Windows. It might not be a problem on Windows, but on Mac it's definitely a problem that, let's say I've just compiled this Ducky model, and then I go back to the patch and like, oh, actually I want to change this bit, make it higher pitched, or add another component, and you compile it again, and you put the bundle back in, like if you replace it. It will replace the file, but it won't swap the plugin in memory. So that means you need to close Unity and you have to open it again for it to update. And that is very annoying, I know, but it's the way it is right now. Further in the future, we could look at maybe making some tools to make it easier. But I think that's basically it, really, yeah.
Can I see the last slide again? Sorry.
Oh yeah, of course. Yeah.
So like trying to in
Uh-huh.
terminal to do the get some error messages. I don't know.
Let's see.
Already went like for the first one.
Oh yeah, yeah, yeah.
This, it doesn't work.
Okay, so let's do this bit, because I should have talked about it. So if you're doing this for the first time and you've just installed Python 2.7, and you've made sure that it is Python 2.7 by going like this, then you might get some errors which say enum is not installed, nose2 is not installed, and no Jinja2 maybe. And the best way to do this is if you say Python -m pip, pip, that is the Python package manager, install. And then there are the 3 dependencies we need, which are I think they're enum, Jinja2, and is it nose or nose2? I can never remember. Yeah, next will complain about Jinja2, and then I think it's nose or nose2. I don't have I don't have internet here, so I can't check. But
I can check it because you sent over an email.
oh yeah. Yes, just nose. Oh, I don't do know. Nose2. Okay, cool. So yeah, if you run this command, it will Python will automatically get the packages and install them, and then you're good to go for that. It won't do it for me because I'm not connected to the internet.
How about if you don't have pip installed, just install that first?
Pip should be installed with Python, I think. No, if you do Python -m pip. This is why I'm specifying this command, because if you just do pip, it might not work. Is that not working? In fact, there's something I was going to mention as well. When you're doing VR stuff in Unity, I would recommend, or any kind of, for basic heavy stuff, it's fine, but like for as soon as you're using controllers and so on, I find it's much better to use Wise, which is a middleware. Do I have Wise installed here? Yeah. Let me just explain to you what Wise is. Yeah, here I've got a Wise project, I guess. So Wise is basically something that sits in between your game engine and the audio output. So Unity, you might have, I mean, it kind of makes sense that Unity doesn't have like amazing audio capabilities, or like, especially when it comes to stuff like this, you know, it's not built for audio, it's built for games. So like, it's very common in the games industry to either have your own audio programmer and your own audio engine, especially if you're a big studio, or you use something that's called middleware. And middleware was made specifically for like small companies and indie developers eventually, but originally for small companies that needed extra audio features but couldn't afford to integrate them themselves into their own games. And it's a very handy tool. If you're familiar with DAWs and linear editors, it will seem pretty bizarre, the interface, because there's no timeline, there's no waveforms at the beginning. And it's a very, very weird interface that takes some getting used to. But after, if you spend a day with it, just look at a tutorial or something, it's very easy to get your head around. It's just got this very idiosyncratic way of naming things, and the interface is like, seems 20 years old, but the new Wise has a very nice interface, actually. But yeah, you can make Wise plugins in a similar way to how we did it there with the compiler. And what you've got is you've got your audio objects over here. And in here, you can select your audio plugin effects. So you can say add source. And here are some some source plugins that I've already generated, which you can load in over here. I think you can start Wise. Yeah. Okay. So like, you know, there are ways of like previewing sounds in your sound objects. And then once you have Wise, if you have Unity option open, you can connect to it here. It will show up as a remote connection. And so you can play the game in Unity, and you can edit everything you set up here while the game is running. So for example, let's say I've got this object here, and I want the distance fall off to be slightly different, but I need to be in the game to test that. Then you can change the distance fall off here, or whatever it is you're changing. And once you're done with the authoring, you press save, you generate what's called the sound banks or whatever, you generate some files basically, and it will run inside the game behind the scenes. Okay, so like this thing you see here is just an interface to author the Wise project. And then when you're running the game, Wise will be running in the background. So it seems like a kind of detour to get away, go away from Unity to come back to Unity to get audio. But if you're doing, you know, slightly more complicated stuff, it makes a lot of sense. Also, you can make like objects, say, which have, I don't know, like 5 different models on them. You can just instantiate as many of them as you want. You can use all the lovely bonuses of Wise's way of handling assets and objects and so on without having to program it all yourself. Yeah. And also the latency is better for controllers, I think, with the Vive for Unity, if I remember correctly. Yeah. Highly recommend Wise. Yeah.
Can you add sounds to Wise?
Yeah. In the free version, so if you're shipping a game and you want to use Wise, I think you're limited to 200 audio samples. In terms of plugins, you're not limited. Yeah. But yeah, if you have more than 200 audio samples, waveforms, then you need to get the cheapest license, and it goes up from there. Yeah.
When you design concepts for synthesizing sounds,
Yeah.
what is your usual approach?
Well, that's a really good question. Like normally, so there's 2 kind of schools of thought. There's the kind of, well, there's a few different ones, but like the way Andy, do you know Andy Farnell? Like, he made the book Designing Sound. So he wrote a lot of the kind of, he came up with a lot of the concepts behind procedural audio, especially PD concepts, and I definitely highly recommend reading that book if you haven't already, and you're interested in. Designing Sound by Andy Farnell. Yeah, it's just over here, like. Yeah. Anyway, like, so that's a really good overview of like, you know, how to approach models, what is a model, what is a sound effect, and so on. The reason I'm bringing him up is because the way he approaches making models, you know, is very good and solid, but it's quite technical. It's like coming from the physical source and saying, okay, how does the source work? What kind of a mechanical system is this? But then also like, let's listen to the sound and let's do some spectral analysis and so on. In my experience, like over the years of doing this, I found the most useful thing to do is not, obviously, like you get an intuition for physical concepts like the delta, for example, or concepts of air pressure, or, you know, mechanical things, or the way, you know, filters and so on correspond to real life sound sources. But what I've found the most useful is literally to get reference sounds. Say I'm working with a client who's saying I want, I don't know, I want a vacuum cleaner to sound like this or whatever, like, for example. Then the best thing is if they would provide reference sounds, and you go through the reference sounds and you analyze them from lots of different angles. Like, what is the sound? What does it sound like? What are the extreme variations of the sound, right? So you don't just want one sound, you want something that's capturing the whole parameter space of your model. And then you just like use, the most fun approach is to use your ears and identify things that seem salient to you. Because one person hearing a sound might hear a totally different thing to another person hearing, in terms of analysis, you know. One person might detect like how the pitch changes over time, another person might focus more on the granularity of the frequencies or whatever, I don't know. And then you can use lots of spectral analysis. You can, while you know like what the interaction is, you've got the corresponding sound, you can start building models like that with your ear. In my opinion, if you want to do this like a lot and get into it and have fun doing it, it's more fun. It's better to do it that way, I think. But to do that, you need to. Sorry. Cool. Yeah, yeah. Well, that's the thing, you know, because PD and procedural audio seems like a really nerdy audio programmer thing, you know, where it's like you have to know everything about DSP and.
Maximum speed. And why I'm asking is what trying to do things like whistles and things like this. I try to make an approach by just analyzing the sound wave and trying to model it mathematically, but never really got through with that. But it seemed like kind of a potential there. You know, that you see like, oh, it's a sine wave that is just modulated with like a little bit of a transient. Do you ever try to approach it like this? Say like, oh, I could actually just like model this as a mathematical equation.
Yeah, yeah. I mean, that's what you're doing all the time. Like you've got a sound effect. You isolate the sound effect, and it's usually one effect at a time. You're not gonna, you know, change everything at once in the first go. So yeah, you've isolated pitch and a stable frequency there, right? Maybe what you want is not a sine wave, but filtered noise, you know, for a whistle.
Yeah.
Because if you think of a whistle, the way you'd find that out is, say, you've got a recording of a whistle.
Yeah, whistle.
It sounds like a sine wave, yeah? But then, let's say you got a recording of somebody starting to whistle and goes, you know? You see that comes from noise, so that's already an indicator, yeah, we need noise.
That's actually a bad example because we did model that with
Yeah.
filtered noise.
Yeah, but it's just to explain the principle, you know, like that, like the more data points you have, the more you can kind of deduce what is the best synthesis technique. And from there, like it's really, I would suggest using the sound design brain and not the audio programming brain from that point, you know, and think of it like lots of automation curves and VST plugins on top of each other. That's like a much more sane way of thinking of it for me, rather than like very low level DSP stuff.
So do you think it makes more sense to just like try on error a little?
Yeah, totally. Yeah, in my opinion, yeah. But obviously, like you get an intuition for it, and after some time of doing it, you're going to get more familiar with like the low level signal processing concepts and like all the world around it, but at least you've made the main thing designing sounds, you know. And that way you also make models which are your own. They have your fingerprint on them. They're not like, yeah, like something you read in a book or something that's like the obvious way of doing it. No, you've done it because you've spent time designing it, you know, and that's like, that's something I find quite important for procedural audio, because for it to move forward, you need to design unique sounds, right? Otherwise, everybody would be using the same whistle generators and fire generators and, you know, yeah.
Today's been a really, really inspiring in so many ways. Thanks very much.
Oh, thanks.
I just want to say I just tried using the Rebel Tex hosting
Oh, yeah.
of the online compiler and got that to build the Unity plugin as well.
Oh, awesome. So is that up and running? I didn't even know that.
Yeah, I
cool.
just I think they must have just put it. I know that they were talking about hosting it, but I hadn't been able to. I'd always so I'm glad that I could get it to install with the tools you gave us today and with that.
Yeah.
Still had to then do the Xcode build command line bit.
Yeah. And the good thing about using the command line is if you're working on your own project and you've got your own build pipeline, you can just insert it there, and it's quite easy, you know. So there. But yeah, it's good that Reveltech have. I knew they were going to do it, but I didn't know they already did it. That's great. Cool. So that's one good thing. Another thing we need is a maintainer of the repo. Somebody needs to maintain Heavy CC. So as you've probably gathered, I'm more of a sound designer than a audio programmer. And while I know the code base fairly well, I'm not in a position to be maintaining it. So I don't know, we're gonna have to find somebody to maintain it. We also need to think of ideas for how to keep the community together. Maybe we have a forum or some kind of online hosting of resources. So, you know, any ideas you guys have for that, or what you think would be useful? Yeah.
Following like a PD and an audio programming thing on Discord, I find that that's quite a good way to keep people together because yeah, it's just a great platform really. So that could be a potential, especially linking them together. There's a lot of people on the pt2 Discord who are like quite sad.
I mean, on the PD list, the mailing list.
Yeah, there's just one for pure data in general, but obviously it being pure data and then being quite sort of technical from different backgrounds, but a lot of people were using Heavy for various things, a lot of web stuff.
Mm. Yeah, so that's definitely one avenue, yeah, the PD list, yeah.
Is there anyone in this room that would be interested, like specifically, because it's good to have like general level of enthusiasm for something, but ultimately you need someone to be prepared to commit to some time. Is there anyone in this room that has any bandwidth, or feels like that's something they could contribute to, like not take on themselves?
Well, it's something to keep
I'm
in.
just asking a direct question for now.
Yeah,
Interject direct answers sometimes.
it's true. Yeah, you never know. Yeah. But yeah, hopefully we'll keep, you know, this stuff will keep getting maintained. Having said that, the core bits of Heavy, like the PD parsing and the C generation, it's pretty stable. It got to a stage where there are very, very few errors, and if they're there, they haven't really impacted life with Heavy very much over the last 2 years or so. Over the last 1 year, it's become very, very stable. The things are probably gonna stop working first are like the wrapper generators. So like if Unity changes the way like the audio works, which is likely to happen at some point soon, that's all gonna have to change. So, you know, I guess that's the point, right? Like if one of you guys happens to be working on a Unity project, and it turns out the stuff stops working, and you find a solution, it'd be really important to make sure to let everyone else know, and then we can like get our shit together and put it in the repo and fix it for everyone, you know. It's like that kind of thing. Because at the moment, there's no infrastructure for that set in place. So yeah, just need to make sure. Sorry?
How complicated is that sort of thing to do? Because kind of seeing how it's changed over time to be able to implement changes.
Yeah, you definitely want to be quite, you know, like the thing is, you need to also be familiar with the code base, and I guess it's something you can get into, you know, like.
Presumably, there wasn't just one person that did the wrappers for all the different engines, because it would take a level of competence in various engines.
Are we talking mainly about making the wrappers?
Yeah.
Yeah, I mean that depends on the platform. So Wise has a particularly annoying way of making the plugins and installing them and getting them to run across all platforms and making sure it works for the authoring editor as well as for the build. You know, it's got 2 different plugins. And then whereas, you know, the VST one is maybe a bit more straightforward, you know. But at the end of the day, all of these things are going to have one thing in common, which is a place to put the C code, and a place which is normally inside a callback, which gives you where you fill in your samples and process them. And then from there, yeah, it's doable, you know. It's just like you need to have the time and the bit of an idea of what you're doing, but yeah. For example, we have no Unreal wrappers at the moment, no Fmod wrappers, you know. If anybody wanted to make those, you're more than welcome. Yeah. Any more questions?
I'm not sure if you can talk about it, or if you want to talk about it. Your professional work, what is like your day-to-day work?
It's mostly what you've seen here today. It's like I make PD patches. So I work on that side, but also work on the integration side. I've done quite a lot of work with universities, so like projects like Bela, obviously I've been involved in heavily, but then like recently I worked on a project with a fabric, you know, which could sense pressure across the fabric. You could bend it and so on. So you know, in that case, a lot of the work was taming the sensor inputs and making sure you can get something readable. And then after that was like a lot of sound design work to actually make sure the people get the sounds that they want, you know. And very often that means, you know, maybe I don't want purely procedural techniques. Maybe I want a sample here because it makes more sense, or a sampler or something, you know. And then there's other projects for the web, like I don't know if you've seen the Rick and Morty one, but there's one where we had Morty's face. I was working with. No. This was a web widget. I did it with the artist David Lee, who did all the visuals, and it's a browser. Yeah. Yeah. I've never tried it. Is it good? Yeah. All right. Oh wow. Have you tried Superhot before? You should try Superhot. Oh yeah. Is that like the? Okay. Ah really? Oh, cool. Yeah. That's awesome. Yeah, I need to try it.
Sorry. So what is this project?
Oh yeah, if you sorry, I don't have any internet here, but if you Google.
There is a guest network, sorry.
Oh, is there?
Yeah, let me just find it.
I found David Lee. Quite curious. Seems to be very interesting work.
Oh yeah. There's a new project we're working on right now, actually. Angela, can you? Is it this that you mean?
No, you
Okay.
can actually, there's a network. If you go to QM guest, and then,
QM guest?
and the password is uppercase B. This is probably really irritating me to read it out, but uppercase B, lowercase r, lowercase I.
Where do I put in the password? Ah. Okay. What's the username?
What did you guys use for username?
Ah, the QM events. Okay. What is it?
Password. So uppercase B, lowercase r, lowercase I, uppercase N, 2833.
So, so this was when we did last August together. I think that's going to be a bit slow because my GPU is broken. Yeah, it's very, very slow, unfortunately, because of the GPU on my MacBook is broken. Well, yeah, if you try it on your computer or on a phone, it might work on a phone as well. All the sound is generated procedurally. So, like to answer your question, you know, like here, when we started, it was more like question: how well can you make meat sounds? Like, yeah, I think I can. Yeah, I can make like stretchy rubber sounds. Like, yeah, I definitely can. And he gave me lots of references, like lots of really gross sounds. You know, like on YouTube, my favorite one was like he sent me these videos of people like doing this on their stomach and then close micing it, and apparently it's a whole.
It's great that there's a YouTube video for anything.
It's a whole community online, apparently. It's like, it's a thing, you know?
The only downside of from my experience from YouTube, like downloading from YouTube, is it comes in MP3.
Ah, yeah, yeah, if you download it. Yeah, yeah, but this is more like, it's just like a reference sound, you know? It's like, that kind of gloopy, I mean, you know, not like that, yeah.
Is that impure data that you wrote that?
The sound, yeah, all the audio is designed in PD, yeah.
How did you get the PD into the web app?
It's using Heavy CC, so Heavy CC has a web target, and it's and yeah, and you can put the JavaScript in the website and load it. Yeah. Yeah, so there's a new one of these coming out in a few weeks, maybe even as early as next week. Yeah, the new one's like topping this one a bit. Like it's cool. Hopefully you'll hear about it when it comes out. And then other things are more traditional game clients, you know. But it's always like I ask for a reference sound and then I try and after some time you get an intuition for what's the most basic way of doing that sound, and then you keep polishing it. And sometimes you have 2 days to polish it. Sometimes you have 2 months to polish it, and obviously it sounds better if you spend more time on it. Yeah. And then after that, that's not the end of it, because you might have made an amazing model, but then you load it on the web, and it turns out it's not running at all because all the other stuff is taking up all the CPU computation time, or you're running it on a Bela and there's just not enough processing power. So there's a whole nother round of taking stuff out of the patch at the end to optimize it, or you know, or to fix certain things, or rewriting it to make sure it's fast. But always sound comes first, and then.
One question I had actually, how do you check the CPU load of the actual patch? Like, how do you do optimization and see how well it's running?
That's a good question. It kind of depends on your environment. So like on the web, you can use the profiler, you know, in the browser. PD, you can probably check like, you know, the operating system profile of the patch, but PD is not necessarily a good representation of. It's always going to be higher, but it's not always proportionally the same necessarily.
Another thing I'm wondering about, like I can't remember where I found out about it, but apparently things like number boxes use up quite a bit of
On PD?
Yeah,
Yeah, that's a PD thing. That is, yeah, that's the thing I was told as well, which is, and it's true. Basically, if you, let's say you've got your number box here, and then +5, and you want to put it into this box, right? If you put a number box here and you connect it to here, right? Then this is potentially going to slow down your patch because of the way, I don't know, Miller might have fixed it in the last version. I don't know if it's fixed, but basically, if the connection has to go through the number object in order to come out of here, then you might start losing cycles because it has to compute the entire UI system every time it updates.
Does that translate into heavy as well?
No, not at all. No, the number boxes are just removed. Like they're, yeah. But the thing in heavy to avoid that is to always do this. You see, so always branch the connection. Don't let an important connection go through the UI object. And yeah, it's the same like even on my Windows machine, like an extremely fast machine. If you have a patch that's really big, full of objects and lots of stuff moving, it can really slow down PD a lot. Yeah.
Does graph on parent affect it at all, or is that ignored because the GUI is ignored so long as it's not, so long as nothing's compulsory in the signal chain?
Yeah, it's fine. And graph and parent, I guess, is essentially the same as normal abstraction at the end of the day. But yeah, it's useful to use graph and parent, for example, for let's say if you've got receive, you know, your heavy parameter here. And you're making an interface where you've always got like a slider, you know, number box maybe, and then you want to send this to your internal frequency parameter, and you need to copy and paste this for everyone. It might make more sense to make a graph and parent abstraction for yourself, which you use for all your patches, you know. and that will work fine in Heavy.
Is there a list online of the objects you can use in Heavy? Because the website link to this isn't working.
Yeah, isn't it on the GitHub page somewhere?
No, it links to the engine.
Ah, okay. Yeah, I'll.
I'm not sure if that was changed. I've used the Wayback Machine, but I'm not sure if they've added anything to it since
Yeah,
2016.
yeah, that hasn't been my answer to that question. Yeah, I'll add it to the GitHub later on. I'll add it to the list, or I'll tell Joe and Martin. Yeah.
Making my own little article over. Yeah, basically.
Sorry.
I'm making my own sort of articles just for like people interested who haven't come to this or just in general.
Oh, that's awesome. Yeah, cool. That's really
I
cool.
wanted to link to that, but all I can do is just make it on a Google Doc and then just link people to that for now.
Yeah, yeah. And the list, you'll definitely find it on the Wayback Machine, and then you can.
Yeah, I just wasn't sure if there'd been like any additions since then.
No, no, no. There haven't been any additions to that in a long time, actually. Yeah.
Just like a random question: why is VLine not supported natively? This is one thing I just see. Anypanel uses in loads of his patches, but for some reason it just. I know you have a separate heavy lib patch code.
Yeah, yeah, yeah.
Why it wasn't supported on the get-go.
Well, the thing with VLine is that basically when Heavy was written, there were some very strong philosophical opinions about how it should be written.
Right.
And VLine was one of those things that's, I think it's because it's a dynamic object, you know, it can have like lots of different states and stages that like, it was impossible or very difficult to implement it in a way that stuck to our, like the Heavy philosophy or whatever. That's hence the rewrite. But I do agree sometimes that a VLine would be very useful.
There's the heavy VLine thing that you can use and it works.
Yeah, the thing with that one is that in Heavy you'll probably get the expected behavior, but in PD you're not going to get the expected behavior because VLine is sample accurate. So in PD it's going to truncate at the block boundaries every 64 samples. Yeah. Yeah. Add that to the list. Yeah. There are ways around it though, around using VLine. Yeah.
Tutorials for that? Because I couldn't really figure it out. There seemed to be not much improvement. Couldn't even really find out what the difference.
And if you want to use VLine as you can use the heavy lib alternative. But what I mean is, if you want to do different types of envelopes and so on, there are different approaches you can take, which don't require VLine.
Like drawing into an array.
Yeah, for example. Yeah.
Cool.
Shall we call it a day?
Yeah, let's call it a day. Thanks very much.
Thanks so much, guys. Yeah, thanks for coming, everybody, and thanks to Angela for hosting me and this amazing weekend.